All right, our last speaker of this session before our next question and answer session is Jake Bleacher, and he'll be giving us an update from the Science and Technology Utilization Office. Before Jake gets started, just a reminder to type any questions you might have in the chat. All right, Jake, please take it away.
Thanks, Deborah. And I'll talk a little bit today about how we're doing the utilization planning for human exploration. Utilization, just to define that here, what that word means is basically how do we use the architecture we're developing in order to meet the objectives that the agency has. Next slide, please. So again, we're going to the moon, okay? We're going to the south pole of the moon. And so to really figure out how to develop an architecture and how to build the elements that we want, we have to start with kind of why are we going? What is it that we want to do at the moon? Next slide, please. And so we've heard a little bit sprinkled in about some of the objectives that we would hope to address. Here's a slide that summarizes kind of the high level objectives that were listed out in the science definition report for Artemis 3. And then, of course, that report went into more detail about each one of these. But this is the important information that we pull from an ESDMD in order to figure out how to build that architecture. Next slide, please. And of course, there are science objectives. There's also technology objectives. So if you signed in at the beginning, you heard Walt Englund talk a little bit about the development of the planning for what we would like to do from a technology perspective, STMD's roles. But here, again, a list of some of those high-level objectives that are trying to be met. Next slide, please. In addition to the research, about the moon, about the space environment, we also are trying to learn about the environment that our astronauts will be exposed to, as well as our hardware. So we're trying to understand the hazards of human spaceflight. This is critical for us to move beyond low Earth orbit, not only to just go to the moon and come home, but to spend more and more time on the moon, explore more of the moon, and eventually take those next steps to explore the rest of the solar system as well. Next slide, please. So it's these objectives that help us decide how to build an architecture. And so I'll use the next couple slides to show how we're trying to track those objectives and how they drive out requirements for our systems. This is just showing the directorate level technical documentation for our Exploration Systems Development Mission Directorate and the Space Operations Mission Development Directorate. We start at the top with the NASA Authorization Act and the NASA Strategic Plan. These documents are the ones that basically govern how our exploration systems are developed. The red circle is around one we call the Utilization Plan, EOMD 006. EOMD 006 is where we go from objectives and document the objectives and then try to influence or help influence the requirements document, EOMD 004. Those requirements then trace down into our programs as requirements that they need to meet. Next slide, please. So this just explains that document as we develop it. It is made public. It has authority from a quad directorate, so all 4 directorates have weighed in on this document and approve it when we put it out for release. Again, the purpose here is to identify how our human exploration missions will support science technology communities as they try to meet their objectives. So it's critical that we get that documented through collaboration with our stakeholder organizations through these documents at the top of our directorate to make sure we're building things the right way as we develop the architecture. Next slide, please. This is just an example of those really top level objectives. Again, this is not going straight down into the weeds about detailed specifics on individual missions. This is just setting at a high level what those goals are. And, for instance, from SMD's perspective, this is heavily influenced by decadal survey reports, by any of the other documentation. I can say for a fact, working with my SMD colleagues, that whenever they work with us to help document some of this content, they trace that from the community documents. And in fact, the lunar surface science workshops are in part a key source for us. But the Artemis 3 science definition team report is a big influence as well. So we break this down into each of our directorates that have utilization goals, as well as multi-directorate goals for us to meet. What's important to understand here is that the directorate that holds the objective owns this part of our document, the HEO006. So at any time, they can propose changes to this. So this is not a human exploration interpretation of what our colleagues have told us. This content is owned by the directorates that write it up. Next slide, please. Now, some of those objectives are not something that is easily met in a single mission, a single landing. Another way to say that is it's not all something that can be met within a single program. So it's not the human landing system program that needs to meet those high-level objectives. It's not the lunar terrain vehicle that needs to meet them. These are objectives that trace across multiple programs within Artemis. And so we identified what we call cornerstone capabilities that enable multiple objectives to be met across multiple elements within the architecture. And this just lists the first 8 that we started working on that. For instance, a good one here, end-to-end sample return, the second one. In order to get samples from the lunar surface, particularly cold samples, if you look at 1.8, operating in cold and shadowed regions, that's not something we've done before. So how do you go get a sample from a cold region and transport it through multiple systems back to Earth so that our science community can start working on them? Those are technologies we have to develop in partnership with STMD and SMD to enable this architecture to meet the goals we have. Next slide, please. So we just talked about the objectives, how the stakeholder organizations bring those objectives forward. We document them at our directorate level documents. They then trace into requirements that feed down to the programs. So around that, you can build an architecture to go out and meet those objectives. So here's kind of the notional plan of elements and programs that we have in mind. The SLS and the Orion are already developed, and we're getting ready for the first test flight, integrated test flight in Artemis 1. Human landing system first contract was agreed to, and SpaceX is providing the first lander for the lunar surface. Um, Gateway elements are already in development as we get ready to put the gateway in place. Obviously, ground systems and space communications and navigation. But we're also looking forward to putting out competitive calls for developing our surface mobility, the lunar terrain vehicle, and eventually ideas that are still in pre-formulation, pressurized rovers or other forms of mobility so that we can make sure that our astronauts can get farther and farther out. We're very close to announcing the spacesuits that we're developing and how those will be applied in this new architecture. And eventually you look at all these elements together and they develop what we refer to as the Artemis Base Camp, or basically multiple elements in place in orbit and on the surface to support activities that meet those objectives. Next slide, please. So you saw this swoosh chart already, as we refer to them from Kathy Kerner just a little bit ago. I think really important point is to note right up there in the top left, LRO. It's kind of been our our guiding spacecraft for what we're doing now. That data that have come back from LRO over the past decade plus, sorry about that, is critical for helping us plan where we're going globally with some of SMD's CLIPS landings, as well as our human activities focused more in the South Polar region. So we're working towards that first flight, Artemis 1, coming up, that will eventually lead us to the third Artemis mission, which is the landing of crews in the South Pole. Next slide, please. All throughout that swoosh that you see right there, those hardware elements are opportunities for science. And as Brad talked about, we work really hard between the directorates to identify places where opportunities will exist. And then SMD or STMD identify ways to engage the community and fund those activities to help meet the objectives. So Artemis 1 coming up, we have a number of secondary payloads. Kathy referred to that, and here's a list of them. This is just tremendous opportunity. We're studying the moon from this first Artemis launch through a number of CubeSats. We'll be studying the space environment. We'll be studying how to navigate in deep space. Just, a wonderful opportunity to conduct research across multiple different themes as we move forward. Next slide, please. There are also payloads on the inside. These are mostly focused on understanding how that environment within which we'll operate will be impacting our life, our crew, anything else that we're sending along with us as we explore the moon. So understanding Bioexperiment 1 will help us understand the impact of the radiation environment on biology. How does that impact our crew specifically? Next slide, please. With Gateway, we also have early identified payloads that will launch. Thomas mentioned one of these right at the beginning, Hermes, which is a NASA-provided payload that's understanding space weather. So basically using the Gateway as a platform to study that environment where we'll be sending our crew eventually. And so basically you could kind of think about this as Gateway is joining the heliophysics fleet for understanding that space environment and studying the sun. This also is in collaboration with ESA. So getting these data early from the spacecraft we're sending out before we send the crew will help us understand that radiation environment, going back to those objectives for understanding the hazards of spaceflight. Next slide, please. All of this that we showed in the first swoosh chart is leading up to the continued buildup, development of capabilities, development of hardware that will really start to push towards getting into the more detailed science objectives, research technology objectives that our agency has. And so this is my last slide. We can certainly talk about it if we have questions, but this is the vision we have, building up our assets on the surface so that we can conduct better and better research on the moon and explore more and more of the moon as we move forward. So with that, Deborah, I think I'm done. Thank you.
Thanks very much, Jake.